Okay, so today we'll pick back up on naming organic molecules. Okay, remember you have a quiz either today or Wednesday, whenever your session is. Okay, so let's look at another molecule to name. Let's look at naming this one here. Okay, a little simpler molecule, but it will demonstrate a purpose here. Okay. So remember the first rule to name the molecule. What do you do? Okay, circle the parent chain. Okay, so let's find the parent chain. So start at an end. 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. Oh, I got 2 5s. 1, 2, 3, 4, 5. Okay. Now what do I do?
Now you just pick away, you know.
Okay. So here we have a new rule. Okay. If there's a tie, circle the one with more branches. Okay. Is that showing up there?
Mm-hmm.
Okay. If you have a tie in parent chains, circle the one with the most branches. Okay? So here, which one has the most branches?
First one's
This way here?
yeah.
This way just gives you one branch. If I go straight across, I get 2 branches, there and there. Okay? Or you could have gone up this way, got the same thing. Okay? This gives you 2 branches. Okay? And what are those branches? You have what? What's this branch?
Methyl.
Methyl. What's this branch? Ethyl. Which side are we going to number from, the left or the right?
Right.
Okay, because that's closer to the first branch. Okay. So now we have everything set up and ready to go. It's 5 carbons for a parent chain of pentane. So let's put the groups on an alphabetical order. So you have 3 ethyl, 2 methyl, and then pentane. Okay. Any questions how we did that one? Okay, so that's a new rule for the parent chain. Yes, it's the longest, but if you have a tie, choose the one with the most branches. Okay, and then after that, we can go back to the other rules that we used. Okay. All right, so today we're going to get a little bit more complex in naming these molecules. Okay, and what we're going to do now is look at some other groups that can be put on the parent chain. And what we'll call these are isomeric branches. Isomeric branches that you'll want to memorize. Okay? So what are isomeric branches? Let's look at the first one. if, for example, you had a propyl group. How many carbons is a propyl branch?
3.
3. Okay? So one way just have 3 carbons there, and that just sticking off whatever parent chain you might have. Okay? So that's a propyl group. But there's another way you could arrange these atoms to have 3 carbons. Okay? Could have it like that, where instead of it straight across, now the attachment to the parent chain is on the middle carbon. See that? Instead of the end carbon. Okay? These are what we call isomeric branches. They're still 3 carbons. They're isomers of each other. Okay? So this one here is what's called the propyl group, and this one here is what's called the isopropyl group. Be in the way? You're in the way of the cameras. You're in the way of the camera. Okay, so let's look at how these groups look like on a parent chain. Okay. Let's suppose you had something like that. Okay, so you can see your parent chain. The longest is straight across for 1, 2, 3, 4, 5, 6, 7. Okay. What kind of branch is this one here? What's on this 4 carbon? What is that? That's an isopropyl. See that? So it's 3 carbons, but the attachment is on the middle carbon. You see how that works? So isopropyl groups always stick out like a fishtail. See that? So here you would have 4 isopropyl heptane. Okay, for 7 carbons. Okay. Any questions on the isopropyl group? Okay, want to commit that to memory. Okay, you'll get tricked a lot by that. So see how the isopropyl differs, for example, from the regular propyl. Okay. Okay, so there's a regular propyl. So what's the difference in the name? You just put what? 4 propyl heptane. Okay, question?
What a 4 coming from? Because it's branched out to 4. The 4 from the name. They'll use 4.
The 4 tells you where the branch is.
Okay.
Yeah. Okay, any other questions there? Okay. So that's our first set of isomeric branches, the propyl. Now we're going to go on to the next set, which are 4 carbons for the butyl. And there's going to be a lot more in this one. Okay. Let's go ahead and look at the butyl branches. So here's the first butyl branch that you should already be familiar with, just 4 carbons straight across, okay? And again, this dash here means that this is where it's connected to the parent chain, okay? So here, this is just regular butyl group. That should not be new to you, okay? Now let's make an isomer of the butyl group. This one here, okay? So here I'm moving this N carbon into here, okay? So you can almost see that it's almost like an isopropyl group, isn't it? Except you have this extra CH2, okay? See the fishtail? That's always an indicator. So here, this is what's called the isobutyl group, okay? So you want to commit that to memory, the isobutyl, okay? But with the butyl group, since we have 4 carbons, we're going to have more isomers than the regular propyl group, okay? So how can we do that? Okay, you can't sit in that seat. Sit right there. So the next isomer group will be this one here. So note this one here, the parent chain is connected on the second carbon of the butyl. See that? Over here was the first carbon of the butyl. Now moving the attachment to the second carbon. And so we're going to call this a sec-butyl group. Okay, the sec-butyl group. Or it's oftentimes abbreviated as the S-butyl group. You going to take any notes? Just have to absorb it. Okay, so that's the sec-butyl group. Okay. Now there's one more butyl group. Okay, let's take a look at that. That's where we arrange the carbons like that, all clustered around this middle carbon. It's another isomer. And that looks kind of like what letter? T, okay? So we're going to call this the T-butyl group. The T-butyl group, okay? That is really an abbreviation for the tert butyl group, okay? We'll see what these tert and sec really stand for in a little bit. But for right now, that's what you want to memorize these groups as, okay? Let's do some examples and see what they look like in real molecules. Okay, so I'm going to erase them, but you should have them in your notes. Let's take a look at that one. Anybody see what branch that is sticking off the parent chain? What's that look like? Okay, that's the isobutyl. See how that's the isobutyl? Okay, so if we number the parent chain, let's just cut it at 10 carbons. Okay. So here we would have a 5 isobutyl decane. Okay, so any questions on that one? Okay. Let's take a look at another example. Something like that. If this straight across here was the parent chain, what group does that look like it is there? Which butyl is that? The sec butyl or the S butyl. Okay. But is this going to be the parent chain straight across? Where's the parent chain going to be? It's actually going to have to dip down here. Okay? So the parent chain is actually going to swing up this way. Okay? Because that's going to be the longest chain. 1, 2, 3, 4, 5, 6, 7, 8. If I go across, 1, 2, 3, 4, 5, 6, 7. Okay? So the parent chain will be this way here. Okay, for 8 carbons. So even though it looks like I had an S-butyl, that really got transformed into part of the parent chain. Okay, so you have to be on watch for that. And so I have groups at the 3 and the 4 carbons. At the 4 carbon, I have a ethyl. And at the 3 carbon, a methyl, and then the parent chain for octane. Okay. Any questions on what we did for that one? Okay. So you have to keep those rules in mind. The key rule is getting the right parent chain. You mess up the parent chain, you mess up everything, and you get a 0 for that. Okay? You'll have one molecule on your quiz this week, which is a naming molecule. We'll see if you get that right. Okay. All right, I'll give you one more to do. You can do this one on your own, and then come back and see if you got it right. can name that molecule, and then we'll move on to something else. Okay. So I'll give you 1 minute, starting now. Okay, your minute is now up. How many carbons are in this parent chain? 9. Okay, so where are they? Was it 1, 2, 3, 4, 5, 6, 7, 8, 9? Is that it there? No. It's down here. Why was it down here?
Because you have more branches.
You get the extra branch. So remember, if you have a tie, choose the one with the most branches. Okay, so there it is. It takes away that, might have been tempted to say that's an isopropyl group, okay? But no, that isopropyl gets bust up because of the parent chain. So now we number it closer to this end. Give us that there. Okay. And then we got what? Ethyls and methyls. Okay. So our ethyls we'll name first because of the alphabet. They're on 3 and 6. So you get a 3,6 diethyl. And then we have methyls on 2, 3, and 7. So we have 2, 3 trimethyl. Okay. So again, the number of numbers better match your prefix. And now the parent chain for nonane. Okay. How many of you got that right? A couple of you? Okay. Okay. It's got to be all right, or it's all wrong. Okay. It's like in football, you don't get half of a touchdown. Isn't that right? Okay. Saw the deer antler stuff, must have worked last night. Maybe it'll work on your knees. Okay, so any questions on that one? Okay, so now you should be able to do the ones in your book. Okay, so jump on those and master the naming of these alkanes. Okay, you'll see a lot of points on the exam that's coming up on it. Okay. All right, let's go on to the next topic. If you're following the outline, it's topic number 7. this topic. It's a pretty easy topic. It's what we call labeling types of carbon and hydrogen. Types of carbon and hydrogen. Okay? So these types, we'll look at carbon types first. Okay, your carbon types can be classified into one of four types. Okay. Primary, secondary, tertiary, and quaternary. Okay? So how do I tell what kind of carbon type I'm dealing with? Let's take a look and see how easy this is. What I do is I look at any carbon in a molecule, like this one, and I ask how many carbons are attached to it. How many carbons are attached to that one? Okay. See, one. Otherwise, somebody said two. Okay? So if there's just one carbon attached to it, it's a primary carbon. If I look at this carbon, how many carbons are attached to it? Two. One and two. So what do you think that is? Secondary. That's a secondary carbon. Okay. If I went down to this carbon here, how many carbons are attached to it? Four. One, 2, 3, and 4. What do you think that's going to be? The quaternary for 4. Okay. And then down here, this one has 1, 2, and 3. So that's a tertiary carbon. Okay. So now you should be able to label all the carbon types in that whole molecule. And yes, you'll have to do that on the exam. Very important. Okay. Oftentimes we'll abbreviate these carbon types. You know, this was a primary. So sometimes we'll abbreviate primary like that, like a 1 degree. Okay. That's a primary. That was a secondary. That was a quaternary, that was a tertiary, and so on. Okay. Any questions how we label the carbon types? Pretty straightforward. Well, that's how we do types of carbon, but what about types of hydrogen? Very easy now. The type of carbon, or hydrogen, is the type of carbon that it's attached to. See how easy that is? So, these 3 hydrogens are what? Primary hydrogens. These 2 hydrogens are what? Secondary hydrogens. Looky here, I can't never have a quaternary hydrogen, can I? Okay, because carbons use all the bonds. So hydrogens will either be primary, secondary, or tertiary. Is there a tertiary hydrogen up here? Yeah, right there. Okay, and then you can label all the rest. Any questions on this? On what, how to label hydrogen and carbon types? Any questions? Okay. Make sure you can do that on the exam. Okay? If I draw a molecule, something like this, I might say, tell me the total number of primary carbons in the molecule. and you count them up. Or I might say, tell me the total number of secondary hydrogens in the molecule. Well, start counting them up. Okay. Let me give you one other question on this. Suppose I gave you this molecule here. Okay. What kind of functional group is that? Alcohol. Let's label the carbon types. Maybe you can help me. I'm not sure. Okay. What kind of carbon is that one?
Primary.
Primary. Good. What kind of carbon is that one?
Secondary.
Secondary. Good. What kind of carbon is that one?
Tertiary.
Oh, got a little controversy there. Yeah. Here are some of you saying tertiary. Okay. No, it's not tertiary, because that is not a carbon. What is the rule? The number of carbons, not anything else. So this carbon here has 1 and 2 carbons on it. So that's a secondary carbon. And lastly, primary at the end. Okay. I might ask you, what is the total number of secondary hydrogens in that molecule? What do you think? What's the total number of secondary hydrogens?
3.
Okay, 3. Okay, so where are they coming from? Well, there's 2 on that one, and there's 1 on that one. Okay, so that was a quick quiz to see if you're still understanding your line bond structures. Okay, so this carbon's used 3 bonds, so there's 1 left over. This carbon used 2 bonds, so there's 2 left over. Any questions on that? Okay, so make sure you're keeping up with your stuff. Okay, so that's kind of the first half of the chapter, of chapter 3. Chapter 3 is the biggest one, okay? So the first half is devoted to all naming. By now you should have naming under your belt. Tackle those naming problems in your homework, okay? And I think what we're going to start doing, something different in your sessions that you meet with George, okay, is that each week I'm going to have you turn in the homework that's due up to that section that we've covered in class. So it's forcing you to do the homework each week and not wait till the end or however you're going to do it, okay? So keep that in mind. George will give you further instructions today, okay? All right, let's look at the next part of chapter 3, okay? Something a lot different. Suppose we wanted to look at this molecule, and I'm not worried about the name, though you should name that pretty easy. What is it? Okay, let's check. I want to look at something different. Okay? This time what we're going to do is look at the properties of the molecule. Okay? And the particular property that we're going to look at is the rotation of a carbon-carbon single bond. Okay? This is what we want to get used to. Anytime you see a single bond between two carbons, that bond can rotate like a steering wheel. Okay? That bond can rotate like a steering wheel. Okay? So for example, if I drew a molecule like this here, for butane, okay, those carbon-carbon bonds can rotate so that that middle bond can rotate to something like that. So that this here will be the same molecule as that there. Okay? So these things can rotate all over the place. Okay? This is what I want you to get used to. So you can see the molecules in different arrays, but they're all the same. All three of those still have what? The same name, butane. They just differ by the rotation of different single bonds. Okay? When molecules differ by rotation of single bonds, they still have the same name, but they have what are called different conformations. Okay? So conformations are simply different rotations of carbon-carbon single bonds. And so sometimes these are what are called conformational isomers. Okay? So conformational isomers are just simply different rotations of carbon-carbon single bonds. Okay? But we're going to look at these in a little bit more detail. Okay? And that there's a certain way to look at them, and they have different energy values associated with them. Okay? And we want to look at these in more detail here. Okay? The first one we're going to look at is ethane. Okay? So let's just get a little quick introduction. You might ask, with ethane, does it have any conformational isomers? Doesn't look like it does, because there's only two carbons, but it does. Okay? Remember, we learned that the molecule is really three-dimensional in structure. Remember, these two carbons were sp3 carbons, okay? And so these carbons were tetrahedral in shape, 109.4, okay? So we can draw this three-dimensionally like this here. Okay? So remember what those symbols stood for? Okay? Because now we're going to start working with them. Okay? So you can write it down again in case you forgot. These wedges mean it's coming out towards you, out of the board. Okay? These dashes mean it's going in away from you into the board. And the lines mean they are in the same plane or